Hi guys, Nisarg here from DataMites. Today's interview question is that what is a big O notation? So a big O notation is a most common asked interview questions, especially in the big companies, because they want to assess you whether even you know this term or not. So why this big O notation is important? Let's see. Okay, so any programmer or a coder, when a programmer or coder writes certain function, it requires that if his or her functionality is optimized in certain way, and that certain way is nothing but time or the space complexity. So what do you mean by time or space complexity of any function? Um, you know, the time complexity is basically the execution time that the function takes for executing its codes and whatever being written inside of it. Okay, that's well and good. So what essentially happens that, when the programmer makes a program which is taking lesser number of inputs, at that point of time, essentially all the programs are optimized in terms of its time complexity. So if two programmers are making the same program for same purpose, both the programs are going to have almost same time complexity, means both the programs are going to take almost same amount of time for its working. The real challenge of a programmer comes when the function is supposed to take a higher number of inputs. The moment a function starts to take a higher number of inputs, at that point of time, the time complexity of the function starts to get rise up very heavily, means it's start to takes a longer time to give the result back. So a big O notation, or the big ordo notation for that matter, is one of the limiting behavior of a function. I can say that it's a limiting behavior of a function when the input size tend towards a particular value or infinity for that matter. Means when we increase the value of the input size of any function, then there is certain limiting behavior of function, and that's what we call as a big O notation. Okay, I'll just come to it and make it explain in a bit more conceptually. Hopefully you'll understand it. So again, one more I can say in this way, that it's a class. It used to classify the algorithm by the how they respond in terms of processing time. Processing time is nothing but it's time complexity when we increase the input size after a certain point. So let's say we have two functionalities. Okay, let's say we have two functionality. I'll just put, let's say this is one of the functionality. Okay, and let's say this is another functionality. So we have, let's call this to be f of n, and this function is c times g of n. So you see, I said that used to classify algorithm in terms of processing time when we increase the input size after a certain point. And that certain point is denoted as n naught. And this is the n, means you can see this x-axis is signifying the number of input sizes, and as we are going along the scale, the number of input sizes are getting increased, and this y-axis is nothing but the time complexity. You can see that there are two functions, f of n, and this is like c times g of n. So both of them, when the input size was small, was having more or less same time complexity, but after a certain point, it rapidly increases. So in terms of notation, in terms of writing, we write this to be f of n is equal to ordo of g of n. And what is the meaning of f of n is equal to ordo of g of n? It simply means that for some value of c, which is of course greater than 0, I'm talking about this c. For some value of c which is greater than 0, and some value of n, we call this to be n naught, which is also greater than 0, such that any n value which is greater than n naught, like any n value in this region, n naught, your function of n is always going to be less than equal to c times g of n. You see, this function f of n is less than c times g of n. And essentially, ordo of gn defines the upper bound for the function fn. Defines the upper bound for the function fn. Which one? Ordo of gn means c times g of n. So a function is always having an upper bound, and that upper bound is represented as function of n equals to ordo of another function, g of n. And this is what we call as big O notation. I hope this tutorial helped you a lot. See you in the next video. Thank you so much.